Hello everyone, welcome back to SNEED-CAST. I'm your host Alexa, and today we're here with our VP of Marketing and Sales, Ken. If you had tuned in to our more recent episode, we had just talked about the history of date coding. This time we're going to be talking about the different technologies used for packaging. We'll be splitting it up between primary packaging and secondary packaging. So Ken, if you'll help us out here.
Sure, yeah. To get us started, we talked a little bit about the history of date coding, as you said, a couple of weeks ago, which was a fun little segment. And then we thought it would be good to just dive into the different technologies that are used for date coding. Of course, it really kind of, it's I think an easy way to separate, like you said, we talked about we'll take primary packaging first and then secondary packaging. Slightly different, there's some overlap in the technologies for both, but in general, you have typically you see a certain type of technologies that are used for primary packaging and some different technologies that are used for the secondary packaging. So that's kind of how we decided to split this up, right, guys?
Right.
But yeah, we'll get into it. I'll start with you, and we'll start, like you said, primary packaging. People, what does primary packaging mean? So primary packaging, as I always like to say, it's the first container that the product is in. One of my favorite examples is ketchup. A bottle of ketchup goes to the store. The bottle that the ketchup is in, that's the primary package. The secondary package is then the package that the bottles are in that make its way to the grocery store. And then you even have tertiary packaging, which we'll get into much later, I guess. But that would be when how do those boxes get to the distribution center? They usually sit on a pallet, and then the pallet is transported via. So that's kind of your primary packaging to your secondary packaging to your tertiary packaging.
So when we're talking about primary packaging, what are some of the different coding technologies that we do see? Just a couple off the top of your head.
Right. So there is basically a few technologies that you see that are the most prevalent across the board for primary packaging. You have the one that's been around the longest, continuous inkjet, or sometimes commonly referred to as CIJ. We also have thermal inkjet, TIJ. Then you have laser, which has come to the fore over the last couple of decades here. It's one of the newer technologies along with thermal inkjet in the space. And of course you have thermal transfer overprint, or TTO, as well. And those are kind of the most common technologies you're going to see for primary packaging.
Okay, and I know that you had mentioned CIJ, Ken. That's really popular here in the industry. It's one of the first ones that we learned about. Can you give us some background on CIJ printing?
Yep. So like I said, continuous inkjet has been around really the longest. It was one of the forefront of date coding technologies. A.B. Dick, the predecessor to Videojet, launched the first commercially viable date coder, the 9600 Videojet, back in the late 60s and 70s. And Videojet has been at the forefront of the industry for date coding really for many, many decades. They may be a competitor of ours, but they were the ones leading the way for a long time. The fun thing about continuous inkjet, the technology itself actually originates even further back into the 1800s. It's based on the siphon recorder, which was used for recording telegraphs. It got to the point where when messages were needed to be transcribed or sent quickly, as opposed to have a human being or an individual have to sit there and handwrite every single letter, they created a system or a machine that would be able to take the telegraph signals and then convert them into a string of characters that could be interpreted in a much quicker way. And then that core fundamental technology behind the siphon recorder is eventually what is also the core fundamental technology behind continuous inkjet.
So then how does continuous inkjet technology work?
Right. So that was, it's a very interesting, unique technology. I'm going to do my best to explain it. There are several YouTube clips out there that you can find that I'll actually show you a demonstration of it. But essentially, it's the best. Actually, a former colleague of mine years ago had a really good way of explaining it to folks that aren't familiar with it. Is if you can picture a water hose. If you think you take a water hose and you shake it up and down really fast, and you take that stream of water and you do that heavy vibrations, you're going to break it into droplets. Okay. That is essentially what's happening on a very small, tiny scale inside the nozzle of a continuous inkjet printer. So there is a stream of ink that is being kind of pushed through or squirted through, whatever you jetted through this. They're going to go through a block that is going to put vibrations on it to break the stream into individual ink droplets. And then it goes through a charging plate where it's given a charge. if it's to be expelled or jetted onto the material, or if it is not to be used, then that drop of ink goes into what is called the return line, the gutter, depending on who makes the printer, they call it different things. That then goes back through there, goes back into the tank or into the ink reservoir within the printer. But essentially the machine, at a very rapid and insane, kind of when you think about it, incomprehensible mentally, those droplets are going through there at such a rapid rate, and they're either being charged or not charged, and that's what's dictating the drops that are then coming out of the nozzle to create the letters that you then see. And that's why when you see the most common date codes in the grocery store, when you look at your milks, your cheeses, all the different types of food that you're looking at, a lot of times you see those what I call pixelated fonts or dot characters or dot matrix characters, and that is the nature of that continuous inkjet, because it's literally just ejecting one drop at a time at a very rapid pace.
Now that we know a little bit more about how this technology works, what would you say are some of the pros and cons with working with CIJ?
Right, we'll start with there is, as much, even though we don't really, we certainly have partners that we can refer you to if continuous inkjet technology is the right fit for you, but unfortunately, that's not what our core focus is, so we don't promote or sell continuous inkjet technology, but that's not to say that there's not a time and a place for it. Essentially, some of the benefits of continuous inkjet, regardless of which vendor you're going with, and there are dozens of them these days. Although Videojet was dominant for a long time, you have Domino, Hitachi, Markham Image, Citronics, just Lynx, many brands out there that you can look to now. But across the board with all of them, really the benefits are you're going to have the widest range of inks to choose from. Why does that matter? Ink is ink, right, Ken? Well, no, it really, when it comes to inkjet coating, all the magic really is in the ink. That's a big differentiator. You need, as we talk to customers, there are custom ink needs. Sometimes customers need color changing inks. They need food safety inks, or rather FDA approved inks, human consumption inks, inks that are resistant to solvents, all types of different needs where if you need a very specific type of ink, CIJ may be the route for you to go. It also has a very high print speed. Typically CIJ printers can easily operate at 1,000 line feet per minute, 1,500 line feet per minute. I think some can even reach 2,000 line feet per minute, which is quite fast. So if you are really moving really fast, if you ever see a clip of a Anheuser-Busch production line or a Coca-Cola production line, those cans are flying. And that's where a continuous inkjet printer is usually going to be found, is in those types of operations. One more is also throw distance. Because it has a pump, typically, most CIG printers this day and age are operated or pushed through by a pump. That's what's creating the flow and the pressure and everything else, so that allows it to have a larger throw distance. What does throw distance mean, Ken? Throw distance is the distance from the print head to the material being printed. So with the CIJ printer, you can sometimes reach up to a ½ an inch away because of the pressure that's coming from that pump there. So those are going to be some of the benefits or situations where a CIJ printer would be appropriate.
So now that we've heard some of the pros, obviously not everything is sunshine and rainbows in the industry. What would you say are some of the cons when we're working with CIJ?
Right, some things to consider if you find that maybe continuous inkjet technology is the best technology for what you need to accomplish. Of course, regardless of which brand you go with, there are some things that you're going to notice is that the upfront cost, the capital investment, is going to be a bit higher than some other technologies. Not the highest. We'll talk about another one that's usually a little bit higher, but you're looking at a general purpose CIJ printer, depending on which brand you get it from, could run anywhere from $6,000 up to $10,000 or more. And then if you get into specialty CIJ printers for pigmented inks or anything like that, then you could run up to $15,000 or more. And not only that's just the cost of the machine, you usually do also need to pay for a technician to come out and install it for you. It is a more complex technology where you typically you're either going to need to send a technician from your facility, an engineer or an individual, or maybe depending on the size of your operation yourself, to get trained or fully trained on the technology to be able to do the installation yourself. Or again, you're going to probably more than likely need to pay to have a technician to come out. So that's an additional upfront cost. And then of course, you do have ongoing service and maintenance with CIJ printers. There's just a lot of moving parts to this technology. Now, they've done a great job over the last couple of decades really trying to consolidate and reduce the amount of maintenance required with a CIJ printer. Different brands or different companies have different approaches there that you can find, but typically speaking, you're always going to look at a CIJ printer needing some sort of interval maintenance. Depending on the brand and the filter and everything else, how often that interval is, maybe every 6 months, maybe once a year. Of course, it's also relevant to how much you're producing and what your volume is. So you're always going to have a certain amount of parts, usually a filter, some solenoids and some other parts that are going to need to be changed. Think of your car. Your car needs an oil change every so often. It's similar with a continuous inkjet printer. So you have that cost you should consider and think about in terms of factoring in your cost of ownership on top of the ink. And if you ever have any incidents with this printer, it's a production environment. We all know that that things can happen. You have variables out there called human operators that are hard to predict. So accidents can happen. If you have any type of incident that can, damage or affect the printer, then you're looking at needing to have a service technician come out or any kind of failures, you're going to need that service technician to come out. So then you're looking at potential downtime while you're waiting for the technician to arrive. And then, of course, that cost of the technician, depending on how many hours they're there and what the service rate is.
So in the beginning, you had mentioned that there's obviously a handful of different technologies, Ken. Now we want to know a little bit more when it comes to laser technology.
Right. So laser, there's two different forms of laser. You have your CO2 laser and your fiber laser. Laser markers were invented in the 60s, really started coming out in the coating world, mid to late 90s, early 2000s. And at first, when they first came out, they were actually thought to be the CIJ killer. I've heard from people that have been in the industry longer than I have. I wasn't quite around back then, but I've heard from folks that have been around that it was a big push at the time that folks were thinking this is going to be the thing to break out for CIJ, and then it ultimately didn't. With CO2, it's a high-speed marker. You can reach up to 2,000 characters per second, and that to me is just, when I try to wrap my head around that number, is unfathomable.
What's the need for that? Like, who?
You're right. So the benefit, if and when you're looking for laser, some of the instances that I come across or talk to folks that are using laser more commonly, one that a lot is permanence of the mark. So when you're laser, you're literally etching something into the side of a water bottle. This day and age, a lot of water bottlers are using laser etchers on their PET bottles that you see. You can actually, if you rub on it, you can feel that it's actually indented into the plastic. So if you need that permanent mark, because obviously once you've etched it in there, there's no rubbing it off like you could potentially see with ink or that type of thing. The other thing also is like, for example, with CIJ, all those different wide range of inks we talked about, many of them are hazardous materials commonly used, made with solvents like methyl ethyl ketone or MEK. And a lot of companies over the last couple of decades are becoming more and more environmentally conscious and wanting to have things that are not hazardous in their facilities, not only for the environment, but also for their employee safety. So the laser marker, you don't have any consumables with it. There are no hazardous materials that you have to store or worry about safety, et cetera, et cetera. So not the lack of consumables and also the safety thing is another common reason why we see folks use the laser machines.
So we know that some of the pros when it comes to laser is how permanent the mark is, how fast or the velocity of it, and the accuracy of it, Ken. You had mentioned previously that while CIJ is expensive, there's a technology that's more expensive than it. So what's the price point that we're looking at when we're talking about laser?
So it can vary a lot. Just some of what I've heard from folks, as well as some internet research and everything else, there's a wide range depending on who you're purchasing it from, and of course whether you're going CO2 or fiber and some other things. But typically you're looking at, on the low end, $15,000, and anywhere all the way up to $35,000. And again, different factors play into that. Of course, whoever you choose to be your supplier, who you're purchasing it from, and whatever additional, of course, whether you're going the CO2 technology or the fiber technology. And then not only that, there are some, not to say that laser doesn't have some safety concerns. I know I just mentioned the MEK ink with CIJ, but laser also, it's a different concern, because when you think about it, if you're etching something onto plastic, you're literally burning plastic as you're doing it. So as you burn plastic, I don't know if I was a little bit of a miscreant when I was a child. I may have melted some plastic in my day. It emits a certain odor and smell. Well, those are actually toxic fumes. And in a production environment, if you're doing that at thousands and thousands per minute or per day, per hour, that you're emitting a lot of fumes up into the air in an enclosed environment that can potentially cause harm to your employees. Mm-hmm. So in that case, in most machines, you're going to want to purchase what's called an exhaust fume with it, or a fume extractor, to exhaust those fumes. I misspoke there. So that's just an additional cost onto that. That's part of what drives it up to that $15,000 to $35,000 mark. And you need to be able to connect it to an existing ducting system, or you need to add ducting to it to be able to take those fumes out. Not only that, it's a laser beam, so you need to have a shield around that beam to protect employees' vision and eyes. It does emit radiation. So those are some safety concerns in and around laser as well. And again, you also need to have a technician to be able to do this installation for you. It's not something that you typically would purchase on your own and do your own installation.
Now that we know a little bit more about laser, we're actually going to be moving into a technology that we're a little bit more familiar with here. We're talking about thermal inkjet technology. So, Ken, if you could give us a rundown about how our favorite type of technology works, that'd be great.
So, yes, of course, thermal inkjet is what we focus on here at SNEED Coating Solutions. A long time ago, I kind of came up with our motto that we've stuck with for so long is keep coding simple. And that is our belief, stemming back from Brian's, is that we believe that technology should be cost-effective and easy for the customer to operate and use. Now, that's just my little sales pitch built in, but essentially it's a cartridge-based technology, very similar to your desktop printer. So a couple decades ago, early 2000s, Hewlett-Packard started offering a license to a couple of industrial printer manufacturers that were interested in seeing if they could build a inkjet coder or date coder around the thermal inkjet cartridge technology, sometimes in the 90s referred to as bubble jet. And that's a little indicator actually to how it works. So thermal inkjet, thermal means heat. What is actually happening inside the cartridge is there is heat being generated that actually causes bubbles at the top that is then creating the pressure to generate the ink droplets to come out of the nozzles at the front. Depending on which cartridge you're using, and HP is not the only cartridge in the game these days. There's another company called Funai that also makes thermal inkjet cartridges for coding. Funai is a Japanese company that most folks probably aren't familiar with, but they may have heard of an old company called Lexmark back in the day. Lexmark printers based out of Kentucky. That is the cartridge. That's the origin. Funai was a Japanese company that bought them out a little over a decade ago now, I think. So anyway, that's kind of the cartridge that's how it got into the industry. Mm-hmm. Couple what's the right word to think of? But innovative companies thought that they would try to create a date coder around this cartridge technology, and they started making some gains in the industry. Today, you have well over 24 HP licensed thermal inkjet coding manufacturers. So it's obviously the technology that has caught on. It's a technology in the very beginning was thought of very skeptically by the industry due to some limitations. There are still some limitations with the cartridge. One of the main limitations is the ink that you can put inside the cartridge. Now, when I started in the industry, we really could only print for secondary packaging, a little teaser for part 2. So originally TIJ was only used for secondary packaging because you could only put water-based inks in there. What does that mean, water-based ink? Well, water-based inks don't dry on hard surfaces like plastic or metal. So the only thing we could print on was paper or cardboard material. That changed significantly probably about 5 to 6 years ago, maybe almost 10, when they started to make breakthroughs with the cartridge design to be able to allow more aggressive solvent-based inks. And that's where we really got into primary packaging. And now TIJ, as I hinted earlier, laser was considered a CIJ killer, but now TIJ is our little CIJ killer. We have many customers that now have a low-cost alternative to CIJ, where that used to be their only option if they wanted to date code on cans or bottles or jars or things of that nature. Now they have something that it's a little bit more affordable.
So when we're talking about TIJ, what would you say are some instances that we would pick it over or any other printing technology?
Right. So in my eyes, really, it's a matter of a process of elimination, like with CIJ. if you don't need a specialty ink, if you don't need that higher print speed, if you don't need that higher throw distance, then what are you ultimately paying the extra money for? Why buy that printer as opposed to if you have a printer? If with thermal inkjet we can print up to 3 prints per second. That's not nearly as fast as CIJ, which can get 10 or 12 or 15 prints per second. But many customers don't need to print that fast. Like I said, the example I used earlier was a Coca-Cola or an Anheuser-Busch. You know, not everybody is producing at that output. If you don't need specialty inks, you know, if you're not one of those folks that need a color changing ink, or you need an ink that is safe for human consumption, you just need to print a date code on a package. Chances are thermal inkjet will work for you depending on what kind of dry time you need. And then throw distance. That's kind of a limitation with thermal inkjet. So what we pride ourselves on with thermal inkjet, or why we love the technology so much, is because everything is centered around that cartridge. The print head's inside the cartridge. There are no other moving parts. There's no filters. There's no pumps, solenoids, valves, any of these things. Everything is inside the cartridge. So that means there's no maintenance or service, and which is a huge benefit and a lower cost of operation, etc. But with that, because there is no pump, it limits how far the ink can eject itself, or it can be ejected from the nozzle plate. So with thermal inkjet, you have a much lower throw distance. You really need to be within 6 millimeters, which is roughly a 1/4 inch. And ideally even as close as 2 to 4 millimeters for the best possible print possible. At 6 millimeters, you do start to see some degradation and some blurring of the print. So that is, if a customer is not able to really get that print head right up against you know, the surface they're trying to print on, which is doable. We have many customers doing it as long as you got some guide rails in place and uniform conveyors that can feed the product past, then that's where you're looking at. So again, my methodology is always just process of elimination. Do you have some needs that justify the larger cost, and what exactly are your needs? So if you don't need the higher print speed, if you don't need the wide range of inks, if you're not looking for permanent prints like laser, again with laser also higher print speeds, then the thermal inkjet really is a good option for you to consider.
So speaking of cost, how much would you say that a TIJ system would typically cost you?
Right. So just running the game, we're for a single head TIJ system or thermal inkjet with a single head, which is a 1/2 inch tall print head with a controller and everything else, it can run anywhere from about $1,000 up to, we also see some folks out there with systems for about $5,000, which is on the very, very high end.
Right.
So you're typically probably going to be in the $1,000 to $2,000 range if you're looking at getting a single head thermal inkjet printer. And with that, that's the cost of the printer. And 9 times out of 10, I can speak to our printers, but most of the ones I see out there as well, and it doesn't require a technician. You can buy it off the internet. You can buy it from our website, and we have videos that show you step by step how to do it. And most customers are able to set it up on their own without even calling our support line within about 30 minutes to an hour. So you're self-sufficient. You don't have to rely on an outside technician. You can install it yourself, and you have a lower upfront capital requirement. We frequently have customers that will call in, why is your printer so much cheaper than this XYZ, I don't want to name drop, but whatever CIJ printer? And then it's just a matter of breaking down, well, it's a little bit more of a complex technology. There's more parts involved in the CIJ, so that drives that cost up. Well, why would I buy it? And then, Mr. Customer, do you need this? Do you need this kind of specialty ink? Do you need a higher print speed? I don't need any of that. Well, then, Mr. Customer, I think you should consider maybe thermal inkjet might be a worthwhile endeavor for you.
So Ken, now that we've made it through CIJ, laser, and thermal inkjet technology, we want to know a little bit more about thermal transfer over print. So how would you say it works?
Yeah, thermal transfer over print, frequently in the industry called TTO. Most commonly, you're going to see it on produce packaging and potato chip or snack packaging. Very common in packaging machines where there's a flat roll of film, usually before it's formed into a pouch. It's I can liken it to a stamping technology. So it uses ink ribbons that are run through a spool, and then essentially the packaging material runs underneath it, and then the head comes down and stamps it, and essentially it emblazons whatever you're printing. So if you have a 2-inch wide swath of ribbon, Your stamp is going to come down there and create whatever you've created inside your print window, and then it's going to transfer with heat. It'll transfer that ink off of the ribbon onto the surface you're printing on, and then it'll pop up, and then it'll move through. So it's kind of it'll move and go, because it does require that basically the packaging material stops briefly for that print head to come down there and make that impression and emblazon the ink rather. So
So when we're talking about TTO, what would you say are some of the pros and cons when working with this different type of technology?
So, it's high resolution. It is, so you can get a very nice, clean, crisp print. High quality prints can typically get some good speeds, and for the most part, very minimal maintenance, no mess. There's no ink spilling or anything of that nature. So those are kind of some of your most prevalent pros with that.
When we're talking about the cons, we've talked about price points for all of our other technologies. Where would you say that this one ranges? Is it more on the expensive side? Are we still talking affordable?
So it's probably somewhere between CIJ and thermal inkjet, from what I can tell. But it is, again, it's something that you're going to need. You're going to need somebody to come out there and install it for you. It's typically not something that you can buy and attach to. You'll see it attached to VFFS machines, vertical form fill seal machines, or horizontal ones, those types of machines. And it's not something that you typically are going to want to install on your own. So again, that just adds to that cost. If and when you do have maintenance with it, it's usually related to that print head mechanism that sometimes will need to be replaced, and that is a cost, of course. But that is typically it. And then one thing is, again, the way I explained it, depending on what you're printing, you may see a lot of spillage or waste with your ribbon. If you have a 2-inch ribbon and you're printing a very small date code, well, that you're only stamping that small date code out of it. The rest of the ink and that part of the ribbon then gets wasted, and then you have a lot of waste there. So those are just a couple of things to consider, with thermal transfer. But again, most common things that we see it used on are those types of, if you go out and look at your produce packaging, your pre-packaged lettuce mixes or potato chips and such, that's usually the thermal transfer print that you see on those types of. Not to say that other technologies can't do it, but for a long time, that's kind of been the default in the industry.
Well, Ken, we've made it through CIJ, we've made it through laser, we've made it through TIJ and TTO. We'd now like to take this time, if you have any additional comments on any of these different types of printing technology.
Yeah, I was thinking about something earlier that slipped my mind, but at the end of the day, of course, thermal inkjet is our preference. I've kind of stated as to why. We've worked with a lot of, some of us in the company have worked with continuous inkjet in the past, having worked for an ink manufacturer that specialized in inks for continuous inkjet. Brian, who started the company, cut his teeth working with CIJ customers, and that ultimately is what led him to believing in thermal inkjet when that started coming through and breaking through with the ink types that can print and break through onto primary packaging materials. We just think that if there's not a need for CIJ or these other advanced technologies, which typically 80% of the date coding applications out there isn't, then we believe thermal inkjet is the right way to go, because we think it just eliminates headaches for the operators and the plant personnel, or even depending on the size of your operation, you as the owner. And it makes you self-sufficient in that if you do have an issue potentially with a print head or print quality, the machine doesn't have to go down, because you can just swap the cartridge out. And then you can work with your supplier. If it's us, you can work with our support team on how to recover that cartridge. But you don't have downtime. That's a big part of it too, is the downtime. That's that hidden cost, because you can keep running. Whereas with a continuous inkjet printer or a laser printer, if one of those goes down, if you don't have a backup printer sitting ready, then that entire production line isn't running until you get your printer fixed. And that's a huge kind of what I call a hidden cost that is something that you should take into consideration.
Well, thank you so much for all of this information, Ken. We want to remind everyone that while this was our first episode for the technologies for date coding for primary packaging, we do have a second part coming up for technologies for date coding for secondary packaging. So we want to remind everyone to stay tuned. Like always, we want to remind everyone to like, comment, subscribe, and leave comments down below for any additional topics that you'd like to see us talk about here on the show. Thank you, everyone, and thank you, Ken, for all of the great information. We'll see you guys next time.
Bye.